Hi guys, how are you? Hope you are doing well. Today we are learning how to balance half equation by ion electron method. Before that, let's continue my topic of my topic of calculating oxidation state of any element in the given compound by drawing a structure. I want to add one more compound, that is ferrous acid H2 H2SO5. If you use the formula, like for example, hydrogen 1, 1 times 2 plus x plus minus 2 times 5 equals to 0. 2 plus x minus 10 equals to 0. X minus 8 equals to 0. X equals to 6. X equals to 8, which is not possible. Sulfur has a maximum oxidation state of +6. Oxidation state of any element never exceed to its group number. So sulfur has +6 oxidation state. Why we didn't get the answer by this method? Because of this peroxy linkage. Let's draw the structure. Hydrogen O, sulfur, double bond O, double bond O, O, O. How many hydrogen? 1, 2, 3, 4, 5, and a hydrogen. 5 hydrogen, 5 oxygen, 2 hydrogen, 1, 2, and sulfur. So minus 1 plus 1. Each oxygen minus 2. This is minus 1, minus 1. So here sulfur plus 2. Oxygen and this sulfur. So oxygen minus 1, this sulfur is plus 1. Here from 2 bond, so this oxygen has minus 2 oxidation state and that sulfur has plus 2 oxidation state. And from that side, look at that. Oxygen has minus 1 and this sulfur has plus 1. Minus 1 plus 1, minus 1 plus 1, minus 2 plus 2, minus 2 plus 2. Oxygen, 0. This oxygen, no difference in electronegativity, 0. So this oxygen is minus 1, this hydrogen is plus 1. Look, my plus 1 plus 1, 2 plus 2 plus 2, 4. So oxidation state of sulfur in ferrous acid is +6, which is quite obvious. So sulfur shows +6 oxidation state. Sulfur shows variable oxidation state, but to the maximum extent it shows 6 oxidation state +6 oxidation state. If you follow the formula, we got a wrong answer because of this peroxy linkage. Now we do some question of ions. Sometimes they will ask to find out the oxidation state of any element in the given ions. So we will do the ions. Okay. Oxidation state of any element in the given ions, guys. Find the oxidation state of, find the oxidation state of, find the oxidation state of, find the oxidation state of phosphorus in PO4 3 minus. Find the OS of nitrogen in NO3 minus. Find the OS of oxidation state of chlorine in ClO4 minus perchlorate ion, a B and C. H3PO4 minus. Now NO3 1 minus. Nitrogen X, I don't know, plus oxygen each time 2 times 3 equals to minus 1 here. The overall charge is minus 1. So minus 1 here. X plus minus 6 equals to minus 1. X minus 6 equals to minus 1. X minus 5 equals to 0. So X equals to plus 5. And the same way, ClO4 minus. ClO4 1 minus. Chlorine X plus minus 2 times 8 equals to minus 1. X minus 8 equals to minus 1. X minus 7 equals to 0. X equals to 7. Can I rub the board? Phosphorus in PO3 minus. Let's see phosphorus in PO3 minus. Now, phosphorus PO4 3 minus, overall charge is 3 minus, X minus plus minus 2 times 8 equals to minus 3. X minus 2 times 4, my bad, 2 times 4. So minus 8 equals to minus 3. X minus 5 equals to 0. X equals to plus 5. Yeah. Now, we have a displacement reaction. Displacement reactions are also a redox reaction. Let's work out the oxidation state of any element in the given equation through displacement reaction. Displacement reactions. We know halogens. So in halogens, which are 7 group element, which one is the first element? Fluorine is the first element of halogen. Fluorine is highly reactive because of the small size. Can fluorine displace other halogen from its aqueous solution? Let's see. Can fluorine displace other halogen from its aqueous solution? Now, fluorine, look at that. Halogens, fluorine, chlorine, bromine, iodine. Fluorine displaces chlorine from its aqueous solution. Fluorine displaces bromine from its aqueous solution. Fluorine also displaces iodine from its aqueous solution. This is called group displacement reactions or group displacement law. Group displacement reactions. Fluorine is highly electronegative or highly reactive, so fluorine can displace chlorine, bromine, iodine. F2 plus KCl give aqueous give KF balance 2 plus Cl2 gas come out. What's the oxidation state? 0. Pure element has no oxidation state. Plus 1 minus 1 plus 1 minus 1 0. Look at that. So 0 to become minus 1, minus 1 to become 0. Can you notice that? There will be no change in the oxidation state of the K. So if there will be no change in the oxidation state of any element, that element is called spectator ion. It's just watching the reaction, no change. Look at that. 0 to minus 1. Guys, increase or decrease? 0 to minus 1, going back. So 0 to minus 1. 0 to plus 1. During the course of the displacement reaction or during the course of the reaction, if the oxidation state decreases 0 to minus 1, meaning that element get reduced. So fluorine F2 is reduced. What about the chlorine? Chlorine, look at the oxidation state, minus 1 to 0. Oxidation state increases, meaning it get oxidized. Cl2 is oxidized. Now, one more. Can chlorine displaces bromine and iodine? Yes, chlorine can displaces bromine and chlorine can displaces iodine. Yes. I want to give you one example. So K, instead of KCl, you can use KBr. Cl2 plus KBr plus some bromide, aqueous solution. We'll get KCl, 2 KCl, balance it, 2 KCl. Did I balance here? Yeah, balance here. So 2 here, yeah, 2 KCl, 2 KBr plus C, 2 KCl plus Br2. It displaces bromine. Okay, let's see which one get oxidized and which one get reduced. 0 plus 1, just ignore 2. We are using 2 to balance the equation, not to figure out its oxidation state. Minus 1 plus 1 minus 1, 0. Look at that. Chlorine, 0 to minus 1, decreases, reduced. Minus 1 to 0, increase, oxidized. So chlorine get reduced, gain electron, because chlorine becomes 0 to minus 1, gain electron, and bromine get oxidized, lost 1 electron. Can bromine displace iodine? Yes. Let's see one example. An iodine can't displace any of the halogen in the periodic table. Okay. Now, Br, bromine gas, Br2 plus Ki, 2 Ki becomes Kbr, 2 Kbr plus I2 gas. Okay, what's the oxidation state of bromine? 0 plus 1 minus 1 plus 1 minus 1, 0. Oxidation state of a pure element is 0. Now look at the change. Bromine 0 to becomes minus 1, minus 1 to becomes 0. 0 to minus 1, decrease, so reduced. Minus 1 to 0, increase, so oxidized. They will ask in the examination, they will give you this question and they will ask you which element get oxidized, which element get reduced. The element which get oxidized act as a reducing agent. So if F2 get oxidized, what's the function of F2? Acts as a OA, oxidizing agent. if chlorine get oxidized, act as a reducing agent, well-known reducing agent. So without calculating or without using the formula, without writing the equation, can we quickly figure out which element get oxidized and which element get reduced in this equation? Yes. See, the top one always reduces. So fluorine always reduces in case of chlorine, bromine, and iodine. And if we have chlorine with all these remaining elements, so chlorine get reduces, the top one get always reduces. So this get reduced. Chlorine when react with bromine or when react with iodine get reduces. So top one always reduces. And when bromine react with iodine, bromine get reduces, they get reduced, and iodine always oxidizes. Iodine never reduces. So this is called group displacement reactions or group displacement law. Okay. Look at the question. Predict the elements which have oxidized and reduced in the given equation. So chlorine, when react with the water molecule, what we are getting? We're getting HCl plus HClO or HOCl, same thing, with a bleach. Now we have to see which element get oxidized and which element get reduced. Chlorine, what's the oxidation state of chlorine? 0, hydrogen plus 1, oxygen minus 2. I'm talking about each individual element. I know we have 2 hydrogen times by 2. Plus 1, minus 1. Here, I don't know chlorine. Chlorine never be minus 1 if it is combined with oxygen. Why? Because oxygen is highly electronegative element. So it takes the shape pair of electron. Most of the students, they are putting minus 1, minus 2 and plus 1. That's wrong. So the total is 0. I want to show you here HClO, which is equals to 0. Hydrogen 1, I don't know X chlorine, and oxygen is minus 2 equals to 0. X minus 1 equals to 0. So X equals to plus 1. So hydrogen is plus 1, you know that, plus 1, minus 2, so overall 0. Let's see which element has been oxidized and which element has been reduced. So 0, 0, 2, minus 1, yes, and 0, 2, plus 1. Is there any change in the oxidation state of hydrogen? Nope. And what about the oxygen? Nope. So chlorine, here chlorine 0, 2, minus 1, meaning decrease in the oxidation state, gets reduced. Chlorine 0, 2, plus 1 get oxidized. So the same element, chlorine, here get oxidized and reduced. What type of this reaction is that? Most of my students, they said redox reaction. I do agree. This is a redox reaction, but this is a unique or particular redox reaction. A redox reaction in which the same element get oxidized and reduced. What we call such type of reaction? Any idea? These reactions are called disproportionation reaction. What is a disproportionation reaction? Very important, guys. For AQA, for OCR, for AdExcel, definitely you will get this type of question. This disproportionation reaction. A reaction in which same element get oxidized and reduced is called disproportionation reaction. I will give you some example of disproportionation reaction. What is a disproportionation reaction? It is a type of the redox reaction in which the same element get oxidized and reduced. One more example of disproportionation reaction. Okay, I want to rub that one. Sodium hydroxide when react with chlorine, when chlorine gases passes through the sodium hydroxide, we have two conditions. You can take the cold and dilute sodium hydroxide and hot and concentrated sodium hydroxide, Cl2 plus NaOH, cold and diluted, you are getting NaCl plus NaClO plus H2O. Check whether this is a disproportionation reaction or not. Let's see. Chlorine 0, sodium plus 1, hydrogen minus, oxygen minus 2, hydrogen plus 1, Na plus 1 always, minus 1, Na plus 1, chlorine plus 1, minus 2, hydrogen plus 1, oxygen minus 2. Is there any change in the oxidation state of sodium? No change. Plus 1, plus 1, plus 1, spectator ion. Is there any change in the oxidation state of oxygen? Minus 2, minus 2, minus 2, no change. What about the hydrogen? Is there any change? Plus 1, plus 1, no change. So look at the chlorine. Chlorine here, 0, 0 to become minus 1 and 0 to become plus 1. So this is an example of redox reaction. I will give you one more last redox reaction, and in which the same element get oxidized and reduced. So this is an example of disproportionation reaction. I will give you one more example of disproportionation reaction. Same, when chlorine react with conc and hot sodium hydroxide, what happens? The products are completely different. Hot, this is cold and dilute. We will see the hot and conc NaOH. Hot and conc NaOH. Hot and concentrated NaOH. Sodium hydroxide. Now, chlorine react with sodium hydroxide. The condition here is hot and conc. Chlorine plus NaOH gives NaCl here, sodium chloride NaClO3 plus H2O. How many sodium? You try to balance it, guys. So 5 NaCl, 6 chlorine. So 5 here, 1 balance. 6 sodium, 5 plus 1 balance. How many oxygen? 6 oxygen. 3 here, 3 here. How many hydrogen? 6. Balance. What's the oxidation state of chlorine here? 0 because of the pure element. 0, 0. Sodium plus 1, hydrogen, oxygen minus 2, hydrogen plus 1. Plus 1, minus 1. Plus 1, plus 5, minus 2. I'm talking about each one. When you work out the oxidation state of chlorine here by using the formula, you will get plus 5. Hydrogen plus 1, oxygen minus 2. Just ignore 3. So look at that. What happened? Chlorine 0 to become minus 1 and chlorine 0 to become plus 5. What about the oxidation state of sodium? Plus 1, plus 1, plus 1, no change. So sodium is the spectator ions here. -2, -2, -2. Hydrogen +1, no change. This is also an example of a disproportionation reaction. I want to stop here. If you have any question on the disproportionation reaction or the displacement reaction, please write down in my comment box. And whenever you are free, guys, please watch my videos. Thank you so much.